Please remember, minus in front of the cost means you have to subtract every term. Do not pick and choose. So 50x minus 0.5x squared minus 10x minus 3. Please arrange it in descending order. Negative 0.5x squared plus 40x minus 3. So we went through step number 1. What do I need to find next? So we just went through the function, we created the function. What do I need to find next?
The first derivative.
Very good. So I get negative x plus 40. Good. Now I have to find the critical number or critical numbers. How do I find that? This is never undefined, but p prime of x can be 0, which means x equals 40. So I found the critical number. Now I have to create the table. So here's the table. P prime, p of x. I don't need the second derivative unless you want to verify the max min with it. So here's 40, here is 0. I have to study the sign left and right, but it's too easy because this is a linear function with a negative slope. When you plug in 0, you get positive. When you plug in 50, you will get negative. So this is typical. That's all you need to show. Typical for an absolute maximum or relative maximum. But I have to plug in 40 in the original function in here because I need the y value. So what does this say? It says, so table, sign of the first derivative, we just did that. Now I have to find the value and I'm done. That's all I need. So why I need this? It's because I know that x equals 40, number of units, thousands, millions, whatever, number of units, 40, will create the absolute maximum profit. But there I'm also asked, what is it? So in order to determine that, I'm going to put this in the graphing calculator because that's p of x, and I'm going to plug in 40. So clear everything and put in the function negative 0.5x squared and plus 40x and minus 3 and just second and table, and I want to plug in 40, nothing else. So I got 797. So how will I answer in one sentence? When x number of units produced and sold is 40, the absolute maximum profit will be 797. It could be million, it could be thousands, or whatever. But I guaranteed, by studying the sign of the first derivative, I guarantee that this is a maximum. If I don't study the sign of the first derivative, I cannot conclude. Any questions? Any questions? So once you review the notes and you work on a couple of these problems, you'll never have a difficult situation, ever. So again, function, derivative, critical number, table, sign of the first derivative, and then plug it in. All these problems had the same sequence. Okay. So, graphing, max min. Now let's continue with implicit differentiation. Let's see what this means. Implicit differentiation is in section 3.8. I skipped for now 3.6. We're going to come back to it, but 3.7 is not part of this course. So we have to look at 3.8 and 3.9, and that will be the end of chapter 3. So now we are looking at 3.8. Implicit differentiation. Not difficult, but we have to understand it. Okay, implicit differentiation. Before I explain this, if you give me the function, let's say f of x equals e to 2x plus 3x squared, this is the function given directly, not implicitly. This is given to us directly. You're giving me this function and you're asking me find f prime of x. Okay, I will say 2e to 2x plus 6x. The question is, what happens when I am given an equation and I cannot solve the equation for the function? Or the function, or y, is not a function. So this is easy. You gave me the function and you asked me find the derivative. And it took me a blink to come up with a derivative. But what if I have this situation? And I'm going to copy a problem from the book, or I let you copy it so I can explain. So I let you choose it so I can explain. 359. Okay, so let's say 1 through 14. And then we're going to look at 15 through 28, and then 29 through 33. So let's choose a problem from here. Okay, I'll choose number 7. Let's say x squared y to the third, you can choose the next one, plus x to the third y to the fourth equals 11. And you can say, what is this? What are you talking about? What am I doing here? Yes, it's confusing at first. X is just a variable. And you can say, why is it just a variable? No. Y is a function of x. Notice that this equation cannot be solved for y. Not by hand anyway, not without a program, a computer program. No one can solve this for y. No one. So if you had given me y, then I would have found y prime in a blink. But you cannot give me y. You just gave me this equation. And you asked me to find y prime. We're not going to use this notation. A long time ago, I told you that we also have something called dy over dx, which is the Leibniz notation. He invented it. So can I use y prime? Yes, of course, that's fine. But it is much better to use this notation when we are trying to find an expression for y prime in a situation in which no one can find y. This is not possible. No one can solve this equation for y. If I could, I would directly differentiate, and that is it, right? But I cannot. So I would be using this notation. And one other thing that I was going to say, for example, remember we just solved the equation x squared was, I don't remember, 16. And we said we applied the same procedure to both sides. And we continued from there. In this equation, x squared y to the third plus x to the third y to the fourth equals 11. The same thing, if you remember, we had e to 2x equals 2. We applied natural log to both sides. The same thing here. I am allowed to apply this procedure to both sides. It's the operator, right? I applied an operator to both sides. I applied another operator to both sides. I applied another operator to both sides. Okay, can anyone give us the right-hand side? When I differentiate the right-hand side, what do I get?
0.
Exactly. So now, careful, because here I have to apply the product rule twice. So, the product rule, please remember, first function times the second function prime. The first prime times the second plus the first times the second prime, twice. So the first function prime, 2x, times the second function plus the first function. Can anyone differentiate this? Of course, this is a function. Can anyone differentiate this for us? It's a function to the third power. A function to the third power. Prime. A function to the third prime.
Isn't it 3y to the power of 2 times the inner function
Excellent.
or something?
Times the inner function prime. Excellent, thank you. I bring 3 down. I subtract 1 from the power, but because I'm differentiating a function, I have to write times the inner function prime. This is inner function prime. This is exactly it. Plus, I'm going to erase this because I don't have enough room. So we're going to get 0 on the other side, of course, but not here. Further down my page. Plus, can anyone differentiate now this product? So plus. I continue here, plus. Can anyone differentiate this product for us? X cubed prime.
3 times x squared
Times y to the fourth.
Y to the power of 4
Plus.
plus x cubed times 4y to the power of third times dy over dx.
That's it. Equals 0. Excellent. So now, let's pay attention here. This and this, these two terms, do not have the variable. Now, this is just algebra. This is just solving a linear equation. These two terms have to be moved to the other side, and I will have to change their sign. These two terms are not like terms. What I can do, though, is factor out dy over dx because I cannot add them. They are not like terms. Okay? So I have 3x squared y squared plus 4x to the third y to the third times dy over dx equals. These two are positive on this side, but I have to move them to the other side. And I'm going to put minus in front. 2xy squared plus 3x squared y to the fourth. This goes to the other side, it becomes negative. This goes to the other side, it becomes negative. Remember what I'm asked to find? I'm asked to determine dy over dx. What would you do to determine dy over dx at this point?
Divide both sides by the other function, yeah.
What multiplies this? Excellent. So 2xy squared plus 3x squared y to the fourth, 3x squared y squared plus 4x cubed y to the third. Yes, we can factor out a little bit and simplify it. But I'm more interested in the steps. Do we understand the steps? Now you see now why this is another major application. Finding derivatives or expressions for derivatives of functions that are not given to us directly. They are given to us inside an equation because we cannot solve for y. So yes, I could factor out an x and a y squared, and here an x squared and y squared, and further simplify. We can do that. But I'm more interested in the steps. Now, if you say, what have you accomplished? Nothing. Nothing. You just determined an expression for the derivative of y, but it has y in it. This is not a clean expression. It has the function in it, true. But that's all we wanted. Because now I'm able to evaluate this for x equals and for y equals. If I'm given a point, I can determine the slope of the tangent line to the graph of function y at that point. But you have to give me the point. I plug them in and I find the slope. Although I don't even have the function. I don't have the function, but I was still able to find an expression for its derivative. And I can evaluate it if you give me the point. So let's look at an example like that. That's exactly it. Differentiate implicitly to find dy over dx, the derivative of y with respect to x. Then find the slope of the curve at the given point. So these are more human, not as involved as this one was. So let's choose something else from 15 to 28, in which we're asked to find the slope of the tangent line to the graph of the function I don't have at that particular point. I want to choose a nicer one, like 25. So xy plus y squared minus 2x equals 0. They want us to find the slope of the tangent line. So number one, we don't have the function. No one can solve this for y. Number two, they want us to find an expression for the derivative of a function we don't even have. And number three, they say, okay, you don't have the function, you have an expression for the derivative, but still you're able to find the slope of the tangent line to the graph of the function I don't have at this point. This point, it better verify the equation. They cannot come up with a point that does not verify the equation. Let's check. So 1 times -2 is -2, and then plus 4, and then -2. Yes, it is 0. It has to be. The point has to verify the equation. So they're asking us to find an expression for the derivative, and then plug in x equals 1, y equals -2. As we just did, we're going to differentiate the left-hand side. We're going to differentiate the right-hand side. Can anyone help with differentiating the left-hand side? Just remember, this is a function. I'm going to put a dot underneath it, and this is a function. X is just a simple variable. Can anyone get us started with xy?
Would you apply the product rule to
Absolutely, absolutely, mandatory.
that? So would it be well, it would just be y and then plus x times 1 and then dy dx.
Excellent, perfect, plus. We are here now. Anybody? The first function prime is 1 times the second function plus the first function times the second prime. Now we are here.
Would it be 2y times dy over dx?
Excellent, brilliant. Minus, now we are here. Easy. Anyone? equals 0 prime is
Zero.
excellent. Now remember what we're after. We're after this. We're after this. But x and 2y are not like terms. So we have to factor out dy over dx from these two terms. We have to move y to the other side, and we have to move -2 to the other side. What do I have in parentheses? So from these two terms, I factored out dy over dx. So what do I have in parentheses?
Is
Just
it 2yx?
X plus 2y.
X plus 2y, indeed. So now finally we have to solve this for dy over dx. You understand that after we differentiated, this is just algebra, it's just a linear equation in dy over dx. At the top we have -y plus 2, and at the bottom we have Is this understood? Any questions? All we have to do now is to plug in x equals 1 and y equals -2. Where did I get these numbers from? Right here. This was given to us. Good. So, -2 with negative in front, 2 plus 2 is 4. And this is 1, and this is -4. So the numerator is 4, the denominator is -3, so this is -4/3. So the slope of the tangent line at 1, -2 is -4/3. So I have an equation. I don't even know what y equals to. Still, I was able to find an expression for its derivative. And furthermore, if you give me a point, I can determine exactly the slope of the tangent line at that point. This is huge. I only have an equation. I don't even have y. I was able to find an expression for y prime and plug in the numbers that I'm given, plugging them into the expression, I was able to find the slope of the tangent line to the graph at that point. Any questions? Okay, we have time for another. Would you like to choose another, or do I choose? You want me to choose? Okay, here it is. Good. Here it is. Good. So we have time for another. For each demand equation, differentiate implicitly to find dp over dx. This is not giving us a point. They're just telling us that p is a function of x. Just be careful how you differentiate. Or we just look at another one with a point. It's up to you. But let's choose. And this is the end of this section. That's all I needed to show you. Do you want me to pick, or you pick? Okay, I will pick 29. And in 29 we have p squared plus p plus 2x equals 40. In this expression, I would be able to find an expression. For this equation, I am able to find an expression for p, but it will be terribly looking. For this one, I can. But you don't want to differentiate something like that. It is much easier to simply say, okay, I'm applying the same operator to both sides, and the operator is the differentiation operator, the derivative operator. Good. So now can anyone help with p squared? So p is a function, and the function is a function of x. Can anyone help on the left-hand side?
So would it be 2p times, I guess the inner function, so it'd be dp over dx.
Excellent. Plus the function prime. That's what it is. dp over dx. Plus 2 equals 0. Remember, we are after this. This is our variable. These are not like terms. I cannot combine them. If I cannot combine them, that's fine. I can still continue and move 2 to the other side. But I have to identify what is left in parentheses. So what do I have in parentheses?
Is it just 2p?
Careful. If I don't put something in there, I will not have 2 terms. I have to be very careful. Because I have 2 terms and I have to have 2 terms here. Otherwise, when I distribute, if I only write 2p, how do I get this term? So then in parentheses I have
2p plus 1.
that's it. 2p times 2p times dp over dx is this. And 1 times this must be this. Good. So finally I have dp over dx as negative 2 at the top and 2p plus 1 in the denominator. And that's it. So 3.9, well, I'm not going to start now. I'll stop right this moment. So 3.9 is exactly the same, but I need to explain. So what is left from this chapter is 3.6 and 3.9. That will be for Wednesday, and then we'll start reviewing for test 2. I hope you you're going to review all this over this spring break, and I hope you're already registered for test 2. Yes?